Hello, I'm John Ferris, and this is my VRJ Video Reflection Journal number 6, Pearson Correlation Analysis. I'll be conducting and interpreting a Pearson Correlation Analysis in SPSS. My research question for this particular assignment is there a significant relationship between math scores and reading scores for K-12 students in this data set? Now, using the verb analysis framework, the key phrase as you read the research question is found in the terms relationship between. This indicates a correlational analysis. Because both variables, the math score and the reading score, are continuous and measured at the interval or ratio level, the appropriate statistical test is Pearson correlation. However, I will also evaluate assumptions, and if needed, I will use Spearman's rho as a non-parametric alternative. Now let us look at our hypotheses. If we scroll above to page 2 of the summary report, it states that the null hypothesis states, rather, that there is no statistically significant relationship between math scores and reading scores, or rho equals 0. The alternative hypothesis of that states that there is a statistically significant relationship between math scores and reading scores, in which case rho is not equal to 0. This is a two-tailed test because I am not predicting the direction of the relationship. The alpha level is set at 0.05, which is standard in educational research, and lessens the risk of a type 1 error while maintaining appropriate statistical sensitivity. Next, I will check the assumptions for correlation. Now, first, both variables are continuous, which meets the level of measurement requirement, and that's both math score and the reading score, both measured at the ratio level. Second, I examine linearity using a scatter plot, and the scatter plot shows a positive linear pattern. So this linearity assumption is met. Now at this point, I will stop sharing and my share screen and go to my PDF report to get a better view of both scatter plots and other graphics that we used. Okay, let's go ahead and check through there. And we'll go to our output link and click share. And once we go forward a little bit up to the page, I believe that's where the scatter plot records were recorded. Okay. Now, as we can see, we're looking at the scatter plot. As we check the scatter plots, we see it shows a positive linear pattern. So the linearity assumption is met. From here, we can also assess the normality using the Shapiro-Wilk test. And Shapiro-Wilk, I believe, is shown here on page 4 of the report. As we look at the report, we can see that the results show that the p-values are less than 0.001 for both variables, and this indicates a statistical violation of normality. However, because the sample size is very large, this test is highly sensitive and may detect trivial deviations. Therefore, I also will examine the histograms and QQ plots, which show approximately normal distributions with only minor deviations. And those are shown here with the histogram graphic shown on this page. And as we scroll down to the next page, the QQ plot is also viewed. And this shows approximately, again, normal distributions with only minor deviations. We can also, of course, check the box plots and the QQ plots found here, bottom of page 7. And because normality is statistically violated or demonstrated by this point, I will proceed with both Pearson correlation and Spearman's rho to ensure robust results. Now we'll go ahead and stop sharing at this point, and we will go to the analysis page, or rather the SPSS control board panel, the data sheet itself. Okay, let's see if we can get it to come up here really quick. Okay, and we will add and get to that screen. To run the analysis in SPSS, of course, we need to, of course, go to our K-12 data worksheet, Excel spreadsheet. We'll go to Analyze, Correlate, and from the Correlate pull-down menu, go to Bivariate, and we click on, and this portal will appear. Now, I have already migrated both the math score and the reading score into the variables portal. Once we've completed that process, as shown here, just the reading score, I'll just go back here and put it. All you do is just simply migrate the variables there, the Pearson, and then the Spearman. We'll run those correlations, both, as I said, Pearson and the Spearman's rho correlation as the Spearman's rho will be a non-parametric alternative. Okay, now, once we run that report, we'll go ahead and stop sharing. And we'll go back to our page. Again, our results page. PDF, I should say, the PDF output. Let's go ahead and share screen once again. And let's go ahead and sure we're looking at the right area here. Now, as we said, the Pearson correlation results, you should be able to see them there on your screen. R is equal to 0.102. P is less than 0.001. And the sample size, as shown there, is at 3624. That's for the Pearson correlation. Now we scroll down to the next page, which has the Spearman's rho computations. The Spearman's rho results show that the R coefficient, the RS equals 0.095, P is less than 0.001, and the sample size is 3624. Now we come to the decision making as we gathered all this data. Now, because the p-value is less than the alpha level of 0.05 in both tests, I reject the null hypothesis. This means that there is a statistically significant relationship between math scores and reading scores. Now let's try to grasp the conceptual meaning of this. The results indicate a statistically significant but weak positive relationship between math scores and reading scores. As math scores increase, reading scores tend to increase slightly. However, the strength of the relationship is very weak. The effect size for the Pearson correlation, let's go ahead and scroll that back up so we can see it, R equals 0.102, and the coefficient of determination, R squared, equals 0.01, as shown here, meaning that only about 1% of the variance is shared between the two variables. This indicates minimal practical significance, even though the result is statistically significant. Okay, let's leave it there for a minute. Additionally, Spearman's rho, as shown here, at a similar value of 0.095, this suggests that the results are consistent across both parametric and non-parametric methods. This consistency, I should add, indicates that the relationship is stable and not meaningfully impacted by the violation of normality. As for my closing statement, in all of this research I've conducted, I conclude that both Pearson and Spearman correlations indicate a statistically significant but weak positive relationship between math and reading scores. I'll go ahead and stop sharing here at this point, and then I will simply refer back to my summary sheet template to offer merely just some closing thoughts in these regards in terms of reflection. Interpreting the normality assumption, as I recorded here, did prove to be incredibly difficult. The Shapiro-Wilk test indicated statistical significance for both variables. However, due to the large sample size, the test is highly sensitive and can detect trivial deviations from normality. To address this, visual inspection methods such as histograms and QQ plots were used, which suggested approximate normality. As per reminders of the future, I will definitely make more of an effort to incorporate visual methods such as histograms and QQ plots as I have done here, and will continue to use alongside statistical tests I possibly tend to engage in the future to clearly distinguish statistical significances and practical importance when I'm interpreting these results. Finally, using both parametric and non-parametric tests when assumptions are violated, I have found provides a more comprehensive understanding of the data. This concludes my VRJ Journal number 6. I thank you for your attention and have a great day.